In the last example, I showed you how to use index match with ascending data. So you could find the biggest value less than or equal to some threshold. In this case, we're going to flip it and find the smallest value greater than or equal to some value. All right, so we're just switching our perspective. So instead of searching, going from the bottom and up, we're going to go from the top and go down. And so rather than having ascending data, we need to have descending data. So the first thing you can see is that in my data set here, the percentage grade is now starting at 98% and going down and getting smaller throughout the data. So now it's organized in a descending fashion. If that's how our data is set up, we can still use index match. Let's again get our last names back, match on our parameter. And now instead of selecting a 1 for less than matching, now we're going to do the -1, which is greater than matching. So we're trying to find the first data item, right? The first, in this case, percentage grade, greater than or equal to some threshold. So in this case, the threshold is set at 70%. So we want to find the student with the highest grade, the lowest grade, sorry, greater than or equal to 70%. So once we plug that in, we see Schaefer. So let's check if that's correct. So we go down. We want to find the first thing bigger than 70, but the smallest thing bigger than 70. And 74 is our answer, Miranda Schaefer. All right. So how is the computer thinking about it? Well, it's similar to what was done in the last case, except trying to find the first number. If you recall in the previous case with ascending matching, we try to find the first number bigger than our threshold. Now we're trying to find the first number smaller than our threshold. Our threshold's 70%, so we work downwards, and we don't see anything less than 70% yet. We finally see that Kira Gentry at 67% is less than 70%. But again, we always go back by 1. So we go back by 1, and that gives us Miranda Schaefer. All right, so that's why we're getting Schaefer as the correct answer here. Let's see what happens if we mess up our data a little bit. So for example, if we sort in ascending order instead, what do we get? We get another NA error. And that's because, again, the first grade that it finds is less than 70%. And it can't go back up to the previous row because there is no previous row. So we're getting that hashtag NA error. So again, it's crucial that we sort our data in descending order with match if we're using that -1 argument rather than the 1 argument. So we really have to make sure we pair the match parameter of whether we're doing ascending, descending, or equal to with how our data is sorted.